I'm just going to get started with your video for section 2.6 that follows up on what we did in class about geometric proof. Missy McCarthy, Okemos High School math teacher. So here what you'll learn is a little bit more about writing two-column proofs, which we talked about before in class, and also how to prove geometric theorems by using deductive reasoning. So just to reiterate, a geometric proof is nothing more than starting with a particular hypothesis and then using logic along with definitions, postulates, properties, and previously proven theorems to reach a conclusion. If you've used those things using deductive reasoning, then you would have proven the statement. So when you have a diagram, we talked about this a little bit in class, sometimes accompanying the proof or the thing that you're trying to prove will be a diagram. And when you have a diagram, it's important to note that there are certain things that you can assume by looking at the diagram, and there's certain things that you cannot assume when you're looking at a particular diagram. So here in this chart, we keep track of what you can assume and what you cannot assume when a diagram accompanies your proof. So you can see here are the things that you can assume: collinear points, betweenness of points, coplanar points. You can assume that lines are straight when you're looking at the proof and they appear to be straight. That's a safe assumption to make. You can assume that angles are adjacent. If two angles appear to be a linear pair, it's safe for you to assume that they are. And if angles appear to be vertical angles, it's safe for you to assume that that is the case as well, because you can assume that lines are straight lines. So if you see two intersecting straight lines, you can assume that they form vertical angles. Okay, so when we go to this next diagram here, let's take a look at what it might be safe to assume and what it is not safe to assume based solely on the diagram. Okay, so based on this diagram, there's a couple things that are safe to assume. It is okay to assume that points A, B, and C are collinear. That's one thing that it is safe to assume, that points A, B, and C are collinear. Okay, I'm looking at other things here. It's also safe to assume that points A, B, C, and D are coplanar. If we're looking at the segment AC, it's safe to assume that B is between A and C, because it said betweenness, which means it lies on the same segment. It's also safe to assume that line AC is a straight line. Okay, let's look at the angles now. Looks like it's safe to assume that angle ABD and angle BDC are adjacent angles. Ooh, that should be DBC. And something else that is safe to assume is that ABD and DBC form a linear pair. Okay, things that students might want to assume that are not safe to assume. It is not okay to assume, and I'll change the color here just for emphasis. it is not okay to assume that angle CBD is acute. It is also not safe to assume that angle ABD is obtuse. We cannot use what I call the Billy theorem. We can't say that something is true because it looks like it. No Billy theorem. And another thing we cannot assume, even though it may appear to be so, but we cannot assume that angle AB is congruent to angle BC. So we can't use the Billy theorem. We can't say that things are true. Okay, a theorem is a statement that we're going to actually use for some justifications as we move along here, and we establish that they are definitely true. And so a theorem is a statement that can be proven using a logical argument, deductive reason to be true, and we usually write our theorems, or theorems can be written in this P implies Q format, if P then Q. That's where we would get our given from, if P. And then that's where we get what we're trying to prove in our conclusion, which is Q. So here's a theorem that we can prove. It's not written out in its standard theorem format, but it could be, and I'll show you actually in a second what theorem this is. And this just says, given that angles 1 and 2 are supplementary, so 1 and 2 are supplementary, and that 1 and 3 are congruent, 1 or 3 are congruent, can we prove that 2 and 3 are actually supplementary as well? Oftentimes it's a good idea to come up with a plan before you actually start proving the theorem or writing your two-column proof. And we are given a plan here as to type of logical argument that we're going to use. We're going to use the definition of supplementary and congruent angles in substitution to show that 2 and 3 are actually add up to 180, and then use the definition of supplementary to say that 2 and 3 are supplementary. So to get started here, I'm going to start off by making my two columns. And in the first column, we always have our statements. And then in the second column, our reasons or our justifications. So my first statement is going to be the very first thing I'm given, that angle 1 and angle 2 are indeed supplementary. And that is given. Now, because they're supplementary, I am going to then say that means that the measure of angle 1 plus the measure of angle 2 is equal to 180. And that's by the definition of supplementary. The other thing that we were given then is that angle 1 is congruent to angle 3. And because they're congruent, that means that their measures are equal. And that's by the definition of congruence. Now we have to say that because we don't have any properties that we can use for congruence in terms of substitution, but we do have properties that we can use for equality. So then the fifth thing that I would say, if I take my step 2 and I take my step 4 and I replace angle 1 with angle 3, I'm going to say the measure of angle 3 plus the measure of angle 2 is then equal to 180, and that's using my substitution property of equality. And because they're equal, I can reach my conclusion now that angle 2 and angle 3 are supplementary. And then that is by the definition of supplementary. Now, I can't fit the whole thing in there, but you guys know what it says. Okay, so that theorem actually was what we call the congruent supplements theorem, that says if two angles are supplementary to the same angle, then those two angles are congruent. We also have three other important theorems: the congruent complements theorem, the linear pair theorem, and the right angle congruence theorem. So we'll take a look at, or we took a look at proving the linear pair theorem in class, and we're going to take a look at proving the right angle congruence theorem next. And then the proof for the congruent complements theorem is very similar to the congruent supplements theorem. Okay, so here's the right angle congruence theorem. It says use the given plan, but you weren't given a plan. I took the plan away because we are actually going to come up with our own plan to write a proof for this particular theorem, which just says if two angles are right angles, then they are congruent. So I'll verbalize what my plan is, and then we'll get to it. First, I'm going to say if the two angles are right angles, then they're 90 degrees by definition of right angles. If they're 90 degrees, then I can use substitution and say that they're equal to each other, and then therefore conclude that they are congruent. So I got my statements and my reasons. And I am going to start off by saying that angle 1 and angle 2 are right angles. And that was given. Then secondly, because they're right angles, I can say that that means the measure of angle 1 is equal to 90, and the measure of angle 2 is also equal to 90 degrees. And that's by the definition of a right angle. If an angle is a right angle, then its measure is equal to 90. Then 3, I can use substitution because they're both equal to 90. That means they're equal to each other. And that is the substitution property of equality. And then lastly, if they're equal to each other, then that means that angle 1 is congruent to angle 2, and that is by the definition of congruence. That's what it means to be congruent. Definition of congruence. Because if their measures are equal, then they are congruent. So that one wasn't so bad. When you're doing the proving process, one of the things you want to do is make sure that you know what the conjecture is that's to be proven. Draw a diagram or use the given diagram that represents the hypothesis of that conjecture. Then state the given information on the diagram, as we talked about in the beginning of the video. State the conclusion so you know where you're trying to get to, and then come up with a plan, an argument to prove that conjecture.